Again, we're going to use a graphing calculator to graph a polynomial in a given viewing rectangle and find the coordinates of all local extrema. Our first polynomial is y equals x to the fourth plus 4x cubed, and we're to graph it in the window -5 to 5 by -30 to 30. So we'll go to the y equals screen, enter x to the fourth plus 4x cubed. Go to the window, enter -5 and 5 for y min and y max. Use the down arrow, enter -30 and 30. Sorry, I missed my -30 there. And 30 for y min and y max. Now we can press graph. We see that there is a local minimum in the third quadrant, and something's happening at the origin. It's not a local minimum or maximum, so it's not an extrema. It's what we call a point of inflection. It's where the curve changes from being what's called concave down to concave up. So we just have a single local minimum to report. And so I'm going to press second trace, choose 3 for minimum, and use the left arrow to move the cursor to the left of the local minimum. Press enter, use the right arrow to move it back to the other side of the local minimum. Press enter, and press enter again to have the calculator compute the minimum, which is at y equals -27. It occurs at -3, correct to 2 decimal places. So the local minimum is -3, -27. Since there is no local maximum, I'll enter D and E for does not exist. Our second example is y equals x to the fourth minus 18x squared plus 32 in the window -5 to 5 by -100 to 100. So I'll go back to the y equals screen, clear the function. I'm also going to clear the key press history. Now I'm going to enter x to the fourth minus 18x squared plus 32. Go to the window screen. We already have the correct boundaries on our x min and x max, but our y min is to be -100 and our y max 100. So now we're ready to press graph and see the graph. It does appear as if our graph is symmetric with respect to the y-axis, which would mean that the polynomial is an even function, and we see that it is, since we will get the same y value if we enter any number and its opposite, since we've got fourth powers and second powers. So we'll only have to identify one of the local minimum, and then we'll take the opposite of the x value to get the other. So I'm going to go second trace, 3 for minimum, move my cursor to the left of the local minimum that is in the fourth quadrant, press enter, move it to the right of that local minimum, press enter a third time to have the calculator do the calculation, and we see that that minimum is at 3, correct to 2 decimal places, and its value is negative 49. So 3, negative 49 is one of the local minima, and negative 3, negative 49 is the other. Now, it certainly appears from the graph that the local maximum is the y-intercept of this graph. We can see that the y-intercept would be 0.32 by plugging in 0 into the equation. So it appears as if our local maximum is 0.32. Let's confirm that. We'll press second trace, this time press 4. Move the cursor back to the left of the local maximum. Press enter. Move it to the right of the local minimum. Press enter one more time, and we confirm that the local maximum is 32. But look what we get for the x value there. If you read it quickly, you think it's negative 4 point something. Well, you need to pay attention to the e to the negative 7. That means that the decimal point is 7 to the left of where you see it now. So it would be negative 6 zeros 4275. And so it's an extremely tiny number, and rounded to the nearest hundredth, it would be 0. And it's because of the placement of the pixels here that we're getting that very, very tiny difference. So the actual value is 0.32.